Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
electrolysis, electrolysis of lead bromide, and electrolysis of copper sulfate. So, when ionic compounds are molten or dissolved in water, the ions are free to move. When electricity is passed through the liquid, the compound can be broken down into different substances. So, electrolysis is the decomposition of liquid using electricity. The electrolyte is the liquid that conducts the electricity. The anode is the positive electrode. The cathode is the negative electrode. Anions are negative ions. Cations are positive ions. So we can see from this diagram that we have an electrolyte which has positive and negative ions in. So we can see that the negative ions are moving towards a positively charged electrode, and the positive ions are moving towards the negatively charged electrode. The ions must be free to move, which is only possible when a substance is either in a molten state or is dissolved in water. So, positively charged ions move to the negative electrode during electricity. They receive electrons and are reduced. Negatively charged ions move towards the positive electrode during electrolysis. They lose electrons and are oxidized. So we're explaining why magnesium chloride must be molten or dissolved in water to be electrolyzed. It's because the ions need to be able to move from one electrode to the other, and ions can carry the charge. If we're looking for the name of solutions which decompose which electricity is passing through them, it is the electrolyte. So, all ionic compounds, when molten, can be decomposed using electrolysis. The metal and hydrogen always forms at the cathode. Non-metals always form at the anode. Cations travel to the cathode. Anions travel to the anode. The electrodes are made from inert material such as graphite, which does not get involved in the reaction. And the molten substance being electrolyzed is called the electrolyte. So, if we look at the electrolysis of copper sulfate, so to start off with, copper atoms lose electrons at the anode. The positive copper ions then move towards the negative cathode. The copper gains 2 electrodes at the negative cathode, so pure copper builds up at the cathode and impurities are left behind at the anode. 2 short questions. First one, explain why zinc ions move towards the negative electrode, because the zinc ions are positive, so they move to the opposite charged electrodes. And the second one, if we look at this piece of equipment, someone set it up, so suggest 2 changes the students must make to his apparatus to be able to silver plate the metal spoon, and give your reasons. So to start off with, the solution needs to be silver nitrate, not copper sulfate. Otherwise, copper would be deposited, not silver, and the spoon must be moved to the negative electrode because silver ions have a positive charge.
Thanks for watching.